figure out some of the mathematics involved with continuous pitch bending for audio waves, and ended up drawing lots of waves on a piece of paper. As I was doodling, I came up with a game concept. The idea is, what can be drawn with a wave? When I say wave, I'm referring to a graph where time is on the x-axis and amplitude is on the y-axis. There are certain rules which set up some fun constraints. For instance, since time is linear, the pen can only move to the right and has to constantly do so. The pen cannot be lifted. The pen can be moved up and down freely. With these three simple rules, anything you can draw can be modeled as an audio wave. The constraints are more limiting than you might expect. Let's try and draw a circle, for example. Since we can't move the pen to the left, there's no way to make a simple outline of any closed shape. But what we can do is draw a very dense wave with varying amplitudes to construct a solid-looking form. We can make a lot of different shapes with this technique. How about an hourglass that's been tipped over? But an hourglass is useless in this position, so let's stand it up. Uh-oh, now we've got a problem. Remember, we cannot pick the pen up, and we cannot move the pen to the left, so there is no way to draw this shape with this particular orientation. We can't draw any shape with any horizontal concavity to it. This is what makes the game fun. I wanted to actually create audio waveforms with fun shapes on the computer, but it wasn't the open source audio computer, but it wasn't immediately obvious how to do it with any of the software I had, so I fed some squirrels and kept it churning and sculpting to a wave. But all of the sculpting is symmetrical about the zero line. It also has the ability to add DC offsets to waves, but it doesn't have the flexibility to make it efficient enough to be useful. If only I could use different envelopes for the top and the bottom of a waveform. Oh wait, I can. I flashed on the fact that I could do symmetrical envelopes, then use an extreme DC offset to clip the negative side of the wave, and then undo that DC offset to bring it back to the zero line. All of the negative that I could do symmetrical envelopes, then use an extreme DC offset to clip the negative side of the wave, and then undo that DC offset to bring it back to the zero line. All of the negative data would be completely lost due to the clipping. I could make two different envelopes, one for the top half of a shape and one for the bottom half, and then combine them. The simplest way to make the proper shapes is to start out with a drawing, and then use the appropriate envelopes to match it. I started out with a fish I downloaded from the internet. Now notice there are some areas with horizontal concavity. These areas have to be fixed. So let's make some modifications. Now with the tail we'll have to be a little more creative. I don't just want to fill this area in. That would ruin the form a little too much. But what we can do is put a little curve to it. Look at this. It still maintains the form, essentially, but gets rid of any horizontal concavity. Now I'm going to make some stencils so I can match an envelope to the contours of the fish. We'll have to split it down the center to make one wave shaped like the top half and another wave shaped like the bottom. Now it's simply using the envelope tool to trace the stencil that we made. There. Now I'm going to temporarily offset the top and the bottom by just a smidge so as to not have any cancellation when they're summed. Let's export and re-import to see the final result. Here is a beautiful looking fish wave. Now I know you're dying to hear what it sounds like, and in this case it sounds like the wave I shaped. I used a low frequency sine wave, so it's just going to be a pure tone with some fluctuations in volume and some distortion caused by a bit of DC offsetting. But it can sound like anything you want it to, with some constraints. Here is an example of a cow-shaped waveform. When viewed at this zoom level, it almost seems like magic that a cow-shaped waveform can make the sound of a cow. But if we look at it up close, all the features of a moo sound can be found within. Well, I certainly consider this experiment a success. In the description below this video, there's a download link for the fish and the cow waveforms in case you'd like to try them out yourself. If you have any questions, leave a comment and I'll try to answer them.